afternoon, good evening. Thank you for joining us in this very first tinyML Technical Forum Asia. My name is Wei Xiao. I'm from ARM Machine Learning Ecosystem. It's my huge pleasure to be on the technical program committee of tinyML Asia. Third video poster is from Xailient.
Today's AI are computationally intensive and memory hungry, and so most AI demand powerful CPUs and GPUs. The two major challenges to bring machine learning inferences to ultra-low power devices are power constraints and memory constraints. tinyML applications need both hardware and software capable of performing at an extremely low power. The device's power consumption has to be under a milliwatt. Think of an application to monitor movement of animals in Kruger National Park in South Africa. There is no power supply in the middle of the national park to power up the devices, so it must be battery operable. And because the device is battery operated, it is extremely important for the AI to be small and efficient so that the battery lasts longer. I'm sure you wouldn't want to change the battery of the device every week, or else the maintenance would be just too painful and costly. Today's AI works by brute force. It's inefficient, wasteful, and expensive. That's why Xailient turned to nature to find a better way. Xailient brings ultra-low-powered visual AI for tiny hardwares. Xailient's deep learning-based computer vision models are just 45 KB in size and run at only 63 microjoules per image. That means an AI deployed to detect elephants in Kruger National Park in Africa would run on a coin cell battery for a full year. I use single-class object detection models from Xailient. Here's how you can reproduce these results. First, I would prepare my training dataset, load them into the Xailient platform, and then train a custom model. Other models like pre-trained face detectors have the same low power. You can do this with your own data. So why does this research matter? Deep learning took a new turn when AlexNet won ImageNet Challenge in 2012. From then to 2015, the size of the winning models increased 16 times. Deep learning models are no doubt improving every year, but pay the price in terms of increased model size and power consumption, making it extremely difficult to fit on low-powered, resource-constrained devices. So this is where low-power detectors come to the rescue. You don't need a GPU to run these detectors, nor do you need internet connectivity. And the best thing is that these devices can be powered up on battery. That means you can run your AI anywhere. Detection is the first step in every computer vision pipeline. If you want to count the number of cars in your parking lot, you must first detect cars. These ultra-low power AI models can be used as it is or as a first stage detector in the application pipeline. One use case is a face verification application. A face detector model can be run in always-on mode to act as a visual wake word. If a face is detected in a frame, only then is the face verification model activated. Here's an interesting graph of the power consumption over time for a face verification application. The spikes in the graph are when the face detector module detected a face, and so the face verification model was activated. If we run face detector model at 1 frame per second, then only 63 microwatts are consumed for face detection. While the face detector has the capability to run at 15 frames per second, in this example, we chose 1 frame per second to show how Xailient can further save power by running on a low frame rate.
Thank you. I have to say this is a really fun video poster. Sorry, I didn't announce this earlier. This video poster was from Sabina Pokhrel from Xailient. Her topic was object detection using 63 microjoules. So now we have some questions from the audience. First one. So yeah, wow, 63 microjoules for face detection. Is that even possible? What kind of hardware?
Yeah, thank you. Thank you for the question. Yes, it is possible. And this data that I presented, we have benchmarked that in Sony Semiconductor Solution Corporation's IMX 500 chip.
Okay. So our next question, is the face detection just detecting a face in an image, or does it draw a bounding box on the face too?
The face detection, it draws a bounding box of the face too. It returns a bounding box of all the faces that it detects in a frame.
Thank you.
Thank you.
Yeah, so if you have any other questions for Sabina here, please enter them now. Yeah, we have one more question here. So what else can they do beside face detection? At what energy level?
So we on our platform, console.xailient.com, we have other pre-trained models that are available. One is car detector, the other one is license plate detector. But if you're interested in creating your own model, we have made it possible for you to upload your data set, and you can train your own single class object detector and then download it and use it. So it really depends on what you want to do. And if you have a data set, you can go on and try it by yourself.
So our audience is asking, what's the secret sauce here?
So the secret sauce, it is a proprietary model of Xailient. So our co-founder has come up with this from his PhD research.
Mhm.
Yeah, that's the secret sauce.
So how you are able to get this energy level to
It
run
is,
this type of applications? Yeah,
sorry.
to run this type of applications. Mm.
So it is, so our model is very light. So it is, as I presented, it is only 45 KB in size. The architecture is very, so it's very unique. And yeah, so that's why we are able to run these on tiny devices, and we're able to achieve this low power.
Okay. So is there a paper associated with this? Has it been published?
We have we have a few white papers that we have made available if you want to go into details on these. So they are all available on our website, www.xailient.com.
Thank you. The other question from the audience, are the models quantized?
So our model is unique. So it is so for this, it is a different type of model. So usually the model that we have is called selective attention. So it is a type of model compression, I would say. So it is a different type of model compression, I would say. So this is inspired from how we humans or any other creatures on the planet see with our eyes.
Okay, thank you.
Thank you.
Thank you very much for your poster and addressing our audience questions. We would love to thank our sponsor again to make this event possible and free of charge. So ARM, who provides the software and hardware solutions for tinyML development, we rolled out M55 and U55 micro NPU early this year. And a couple of weeks ago, we rolled out the second generation of micro NPU U65. So if you want to learn more, you should be able to find information in our VIP package. Edge Cortex provides dynamic neural accelerator architecture and co-exploration engine that brings cloud-level performance to the edge. SynSense builds ultra-low power sensing and inference hardware for embedded, mobile, and edge devices. And thank you, our partner organization, Shan, as our conference partner, and our media partners listed on this page. You will find them on our tinyml.org website. So again, thank you for joining us today. This concludes our last day of tinyML Asia 2020. We hope you learned something new in this week, and we hope to see you next year. So please visit tinyml.org for more information. The slide deck and the videos will be posted shortly.